All right, welcome back, and we're back to our relational data model. We have two tables that are separate with the aspirations of making one larger table, right? Join the two together. All right, so let's talk about how we can do this. Well, in each one we have a unique identifier. Okay, a primary key here. Here the unique identifier is ID. But we have a primary key here that is also a unique ID for this table. We'll be able to match it up with the data in this table. See how this works. We have our primary key ID, our foreign key, the key that we join the table on, and another primary key in the other data, class. These do not repeat, right? So we can join this information, and so we can eventually create a table where we have Kermit the Frog, grade, class, and then with that information, how many students were in Kermit the Frog class and who was the instructor in Kermit the Frog's class. Okay, so we got, again, primary key, foreign key, primary key. When we create the join operation, we have a new table. Table 1 plus table 2. Data is now inserted into one table. So we have number of students in each course and instructor for each course added to the data list of students. All right? So that is how a join operation works. It is so extremely useful in ArcGIS. If you think about it, you can have these tables with states, with counties, with census blocks, the census tracts, going back to that discussion earlier of administrative hierarchy. And we could have another table with attribute information for that. So number of deaths per county, number of babies born per county, or within the census block group, the number of families with incomes over 100,000, right? So you can have very specific attribute data, and you can join this attribute data to your shapefile that has then linked to points, lines, and polygons with that geometric representation. Right? And so if you have a primary key on this that you can join to any shapefile, then you've made your shapefile more accessible to mapping a much wider variety of attributes. So, common operations to use with a relational data model. Joins, which match records in both tables based on a common field. You can do projection, which reduces one table in the attribute dimension. Do selections, which you've worked on already, right? Reduce one table to a subset, and a criteria for a selection is called a predicate. So each operation takes one or more tables as input and returns one table as output. Some of the ways that we do this, the selections and the joins, is by using SQL. And in relational data models, SQL is structured query language. This is a formal language for interacting with relational databases, and its implementation and language for relational algebra. So common SQL syntax, which you've actually knowingly or not already used SQL when you use the selection boxes. Say select from where are all examples of SQL syntax. Okay, so how does this relate to you, right? How are you going to use this? In the assignment for this week, I've asked you to download Excel tables from the Florida Charts website. Now there's all kinds of data on Florida Charts about health in Florida by counties. You can get information on HIV rates per county. You can get information on vaccination rates per county. Lots of information to get. And you can have all this county level information, but then how do you map it? Well, you find a shapefile with the counties, and a primary key, such as county name. And we're going to join the Excel tables to the shapefile, and from that be able to produce then choropleth maps that display what you want. The Florida map with, say, death rates or, say, birth rates or whatever you like. But the idea is once you get Excel and your spreadsheets talking with your GIS, you really see a lot of the power in working with attributes and importing that spatial and attribute data and creating the choropleth maps, creating the data analysis that you want to work with. All right, thanks. See you next time.